Who are you calling? Oh, yeah. I've been told I need a bicycle.
Yeah.
One of each.
Your wish is my command.
My
Yeah. Tomorrow is enough day. Well, I'm sorry. I'm sorry. I will.
Because he wants to sell them.
So, self-publishing is an interesting experience because you publish a book and then nothing happens. So when you can go to a publisher,
You can always have your one.
well, yeah.
I mean, thanks for your job.
No, because he's been dead for a while.
Oh,
And he's not as responsible. Or he's very, very opinionated.
It hasn't been supplemented.
I said stay.
Hello, welcome everybody. This is the ISIS working group. Usual IETF note well. Everything which is being told in here really belongs to the IETF. IPR declaration, you all know this. If not, please take a look at the IETF website. Note takers is usually my designated note taker, right? And Mikhail is going to be the Jabber scribe. If you want to add something, right, multiple people can edit IFAPAD. If you think that your name has not been correctly spelled, please fix it instantly. Working group documents on the green dots we're going to talk about today. We've got the new working group document, which is Jeff Swan's on maximum sit depth, which I just want to ask him to resubmit using the new name. We've got two new RFCs. Basically a revision to 4971 and also interestingly an operational issue discovered well more than 25 years after the protocol inception regarding an attack vector using maximum lifetime. New ideas we have in here, again, advertising DE protocols. So Chris is going to entertain us further. And also NVU control plane for ISIS. Among the existing IDs, Anke is going to talk about geolog, what else? Spine leaf topology, and yeah. So, who's first? AutoConf. No presenter for AutoConf?
it would be me.
Yeah? Okay. I knew we have got a volunteer.
Sorry.
You need the clicker less?
Yes.
Okay, I'm Les Ginsberg on behalf of the co-authors. We're going to do something a little perhaps out of policy, but I'm sure Aaliyah will allow it. Because the authors had some discussion off the list after version 3 was published, and we actually have version 4 that we're still finalizing on among the co-authors, and we'll publish it very soon. But I'm going to give you a preview of what's in version 4, because I think the co-authors have largely reached consensus, but we're not quite finalized on the final text. So version 3 made a minor change, just to clarify that autoconfig is meant to apply to small networks. The more substantial change, which is in version 4, has to deal with the problem of double duplication. That is to say, each router auto-assigns a system ID and a hardware fingerprint. And we have in the existing draft solutions for what happens when you have duplicate router IDs. But we didn't have a complete discussion of how to handle the case where both the router ID and the fingerprint are identical. The key issue here, I'm not going to spend a lot of time talking about these detailed parameters, but the key issue here is you have to differentiate between the benign cases and the pathological cases. The benign cases occur when a router restarts and there are stale versions of its LSPs in the network from its previous incarnation. In such a case, you are in fact going to receive your own LSPs from your previous incarnation, and they are going to have the same router ID as you now have, presumably if you haven't changed it, and they're going to have the same fingerprint. But this is a benign case. It will be handled by the normal update procedure. You will generate a new version of your LSP with a higher sequence number. The other routers of the network will update and everything will stabilize. In the pathological case where you actually have two different routers with the same router ID and the same fingerprint, you're going to oscillate back and forth. I'm going to generate a new version. My evil twin will then generate a new version back to me, and we'll continue to do this ad infinitum. And so the procedures defined here basically just say, okay, I'm going to set up a timer, and I'm going to set up a modest number of occurrences where this could be expected. And if I only see one or two of these and it dies out, that means it's the benign case. But if this continues, if I see enough of these, and the number that we've tentatively proposed is 3 occurrences within 60 seconds. Where did we get 60 seconds from? 60 seconds is the ISO 10580 age lifetime, which it was basically defined to guarantee that you allowed enough time for an LSP to propagate through the network. So if you see that many, then you go, I really have an evil twin out there, and then I have to go through my procedures to pick a new router ID, generate a new fingerprint, and remove the duplication. So that's the substantive change. Again, apologies that we didn't get it out soon enough. But we did want to present this while we had the chance. I think that's it. Oh, I'm sorry. There were a couple of other additions in terms of parameters that we had not defined that need to be standardized for auto configuration. One of them is originating LSP buffer size, better known perhaps as LSP MTU. We're proposing 512 here, which is a bit different than the normal default for non-auto config. And the reason for this is to guarantee that it's small enough to be flooded on any link that you might have in your network. So it's just a bit more conservative. Max area addresses is 3, which is the typical default. But these are necessary. They have to be consistent on all routers of the network, or you're not going to form adjacencies. And we just clarified, we've standardized on the use of what are commonly known as the wide metric TLVs. So we're just being a little more explicit in which TLVs are not allowed to be sent for an auto-config implementation. No real substantive changes, clarification. So we will publish the new version soon, hopefully by next week. And then I think we feel like we're ready to go to last call, but obviously the working group needs time to read the new version and be in a position to agree to that or not. Questions?
Any implementations of that, Les?
Not that I'm aware of.
David?
Anybody?
No?
Anybody else? No?
Okay.
Bin Liu, one of the co-authors of the draft, and we actually had, not by us, but by another organization, which is NetDev, if I recall correctly, they had implementation, but hasn't aligned with the newest version.
Mm-hmm.
Yeah. Sorry?
Okay. So.
So I actually don't have the same slides here because the situation is slightly different. I think we had enough sort of debate, so but I'll go through these slides and show you actually the use case that sort of led us to come up with this proposal for ISIS, that is advertising the TE protocols enabled on a link, because I think it's useful just to do that. So in an application using segment routing with centralized bandwidth accounting, so I think we're all aware that segment routing itself doesn't make bandwidth reservations in the network. So if you want to do bandwidth accounting, you need to do it with a centralized controller. And so this is a sample network where you've got a topology and different bandwidths on the link. In this case, it's link aggregation of 10 gigs. So you have 20 gig and 30 gig on the links. And so you're going to want to use BGPLS to learn both the topology and the bandwidth on the links in the SR controller. And this helps the SR controller develop the topology. And then as it pushes label stacks down onto the head-end router, it keeps track of reservations in this database, essentially. So this doesn't show up too well on the slide, but the obvious way to do that is to use the maximum link bandwidth sub-TLV in TLV22 in ISIS. I say obvious, maybe that's a bit loaded, but that's sort of a straightforward way of doing it, given that this already exists. So this leads to a backwards compatibility problem in a special case where, as we discussed before, where you have SR on some links and you don't want RSVP to be attempted to be signaled across those links because it's not enabled. So similarly, SR only network, no problem. RSVP network, no problem. But an SR and RSVP and a network where SR and RSVP are both enabled on the same links, it's also no problem. But there's this use case where you have RSVP also running on the network, and you want to exclude the use of RSVP from that link. Now, but first, I'm going to sort of go back to what do existing RSVP implementations actually do to infer that RSVP is enabled on a link. And it turns out that they use different information in TLV22 and also in the presence of TLV38, the SRLG TLV. So these are various implementations, and these are the TLV and sub-TLVs that cause those implementations to assume that RSVP is enabled on a link. So it includes it in the CSPF and potentially signals an RSVP LSP across it. So in general, we have to deal with the fact that these are out there and in a lot of cases are not going to be upgraded anytime soon, and we should have mechanisms for dealing with this. So in this case, we have, let's see. So we have this problem again in the in this. We go back to the combined scenario of okay, we've got the SR bandwidth accounting application running on this network, but we've also got RSVP that's running on this network. And in this example, you know, Y is going to advertise the bandwidth of this link, which is 30 gig, using the maximum link bandwidth sub-TLV and TLV22. That's going to cause this RSVP ingress router to potentially try to signal an LSP across that. And this operator doesn't want that to happen because, well, they in fact don't have RSVP enabled on this link. So a short-term workaround for this is to simply use admin groups. So a given operator says, okay, admin group 4 means RSVP is not enabled on this link, and configures that admin group on any links on which RSVP is not enabled. And then on the LSPs, on the RSVP headend router, configures the constraint to exclude links with admin group 4. So this provides a solution in the short term, but as I mentioned in the previous discussion, operators generally want some long-term solution to clean this up eventually. So what we have proposed is the TE protocol sub-TLV, which explicitly says RSVP is either enabled or not enabled on a link. And then the RSVP headend router is able to look at that sub-TLV when it has been upgraded as well and understand which links it can and cannot use without having to use the admin group short-term workaround. As I mentioned before, there's some potentially useful new sub-TLV for segment routing, something like bandwidth usable for segment routing. In general, you know, segment routing isn't making bandwidth reservations, but it's useful to be able to carve up the bandwidth for shortest path routed traffic versus, say, SRTE traffic. So just like is done today with RSVP, people will leave, you know, 40% of the bandwidth for the LDP IP shortest path traffic, and then give RSVP a, you know, 60% sandbox. You might do the same thing in segment routing. Now you might ask, why do this in segment routing when the central controller already knows everything? And in general, people are using the network still as the definitive description of the network. So you'd still want to be able to configure, you know, okay, this is a 10 gig link and 6 gig is available for SR. This sub-TLV, this new sub-TLV, would also be able to coexist with the existing bandwidth-related sub-TLVs for RSVP. So in this case, these are the existing bandwidth sub-TLVs for RSVP, maximum reservable bandwidth and unreserved bandwidth, and, you know, divided into the various priorities and so on. So that would be sort of the sandbox for RSVP to use. And then you would also define, you know, from here down, if you wanted to give SRTE 3 gig, then you would define that value, and then you're potentially leaving, say, 1 gig for the other traffic, so that at least in general, you have 1 gig for, you know, IP or LDP traffic, or even segment routing node SID traffic, which isn't tracked by the segment routing TE. So that's sort of the use case that led to this, to our take on this. And so I don't really want anything more contentious debate, but if there are any questions about this, that would be good.
Leskenberg, so I'm going to propose something that I hope we can all agree on easily, which is that the problem that we need to solve in both IGPs is the same. Obviously, the encodings and some of the deployment considerations are a little bit different, but we should all agree that we need the same solution, the equivalent functionality in both IGPs. And if we're going to move in the direction of a use case discussion, requirements definition, that they should be IGP agnostic.
I agree. We'll be singing Kumbaya in a little while.
Hannes, I defer to Chops in Muteco.
Hi, yeah, I would love to sing Kumbaya. That'd be great. So I do have a question. You know, thinking about the question I asked earlier in OSPF about the duplication, is there? Do we ever imagine there being a time where we want to have the same information with different values depending on the application that's using that? You know, that sub TLV.
So it may be the case, and maybe this use case document that we're going to produce jointly between OSPF and ISIS will address that. This example here that I've given is, you know, it illustrates that sort of copying the existing RSVP bandwidth information to SR directly doesn't make sense, because, you know, these, why in the world would you do something with 7 priorities and reservations when in fact reservations and 7 priorities don't exist in SR? So I think in general, like in this case, it would make the most sense to take the time to define the meaning of the new attribute. There may be some cases where it's obviously the same meaning. For example, SRLGs. If we, you know, identify that use case, it's fairly obvious what SRLGs are, and maybe we could decide that there is a use case for advertising different values of SRLGs.
Talk faster. AC Lindum, Cisco Systems. We have in our draft, we didn't get to it because of the other discussion on the basic mechanisms, but we do have use cases where there are in fact different requirement for different SRLGs. And right now we already have, for one thing, is we have different TE metric than we do the IGP metric. So there's already cases where you have different attributes, and this will be resolved in the use case. Discussion.
Adrian Farrell.
Oh, sorry.
So go ahead, Chris.
Oh, I just wanted to say, with the working group chair hat on, that I agree. I agree with Les's idea, and Chris, I think too, that we definitely should try to, you know, do this in both protocols. That's it. So signing off.
So Adrian Farrell, it's no surprise that I quite like this, since we've talked about it offline a fair bit. But could you, just for the sake of completeness, comment on the idea of a solution where you run separate instances of the IGP for the separate use cases?
Haven't really thought about that. I mean, so maybe Stefan would.
Again, as I told in OSPF, you can use multi-topology for this purpose.
Okay. So we can look at that in terms of use cases. However, I mean, in general,
Stefan, you're kind of implying that all the vendors' TE implementations are indeed multi-topology enabled.
That's not the case, but you can implement it.
So, yeah, I think it brings in maybe more complexity than is necessary to solve the problem, because it's not clear that you need to be running different SPFs, for example, which multi-topology would imply. So this might be a point that Les and I agree on, that maybe this is not the best approach, but
even multi-instance, you will be running separate SPFs, so it may not completely solve the problem where, like for example, if you have to advertise different bandwidths for SR and RSVP, you probably don't want to run different SPFs for those.
Yeah.
So probably multi-instance may not be the right direction.
And we're not talking about the CSPF for the traffic engineering stuff you're doing, but just SPF. You'd be sort of replicating, at least in completely different instances, replicating quite a bit of IGP overhead that's bringing no value except giving you a clean way to separate stuff, kind of.
Last word from Les.
Yeah. So that's pretty much what I was going to say. You're proposing, and it's fair enough to discuss this, but you're proposing that we essentially duplicate the topologies solely for the purpose of isolating the attribute advertisements. That's what it seems to me.
Mm-hmm.
So.
Next presentation, please. Sorry, we're tight on time. Where is the clicker?
Hello, everyone. I'm Xiaohu from Huawei. This job talking about how to use ISIS as a control plane for network virtualization overlays, especially for campus networks. Due to success of the NVO within data centers, more and more enterprises are considering to use this technology within their campus networks. Although BGP or SDN controller can still be used as a control plane protocol, it seems a little bit heavyweight, especially for small and medium-sized campus networks. By using ISIS as a control plane, the network provisioning is greatly simplified. That is, only a single protocol is used. This is same as spread the segment routing IGP, which is much important to campus network operators. By propagating the WIN membership across network virtualization engines, these engines belong to same WIN instance could discover one another automatically. The WIN membership information carried in a WIN membership sub-TLV of the following IP reachability TLVs. When above TLV is propagated across level boundaries, the WIN membership information contained in that TLV should be remained. This is the format of the WIN membership information sub-TLV. WIN ID contains a 24-bit globally significant WIN ID for certain attached WIN instances. S flag is used to indicate whether a subdomain ID field is within this handler. This subdomain ID is only used in case where the bomb traffic is forwarded by using the bear forwarding mechanism. This ISIS-based lightweight control plane could work with any NVO data encapsulation format, such as VXLAN or NVGRE, to reach consensus among ingress and egress NVEs about which tunnel technology should be used. The encapsulation capability sub-TLV as described in this draft could be used. MAC addresses for local C host could still be learned by NVEs as normal bridges. That is flood learning mechanism. For learning MAC addresses of remote CE host, there are two options. One is data plan-based MAC learning. Another is control plan-based MAC learning. If unknown unicast flood suppression is strongly required, the control plan-based MAC learning is recommended. Otherwise, the data plan-based MAC learning is recommended. To realize control plan-based MAC learning mechanism, the MAC reachability TLV as defined in this RFC is reduced. The MAC reachability TLVs are contained in RSP, which are further encapsulated with a ISIS header. The source MAC is MAC the originating NVE. The destination MAC is to be defined multicast MAC address, which indicates all NVEs. When NVE is receiving these ISIS frames, they will intercept them and process them accordingly in the form database. Several previous versions of this draft have been submitted to the NVO3 working group. We have implemented a previous version on Linux. It works very well with OS. In addition, as far as I know, there are at least two mainstream vendors have already implemented this similar feature, but I cannot disclose their names until I receive explicit confirmation from them. I'd like to request working group adoption of this draft.
Any opinions on that? Who has read the draft? 1, 2, 3, a couple of people. Okay. Those who have read the draft, are you good for adoption? Any strong feelings? I'll ask the question again on the list. Okay.
Paul Lemihagen of IA. I don't have an opinion on whether it should be or should not be a part of the working group draft, but there is a fair bit of experience in this thing. So I am confused before I get into that about what was already been done in the IEEE for a very similar function with shortest path bridging based on ISIS. We discovered a few things along the path about virtual machines and VNs and how they should attach automatically to the virtual networks created by it to make it seamless. But I did have a question. When you talk about the use of the VN joining, are you referring to using ISIS down on the vSwitch itself, or as an ES-IS or IS-to-IS mode, or is it just up on an actual switch doing the ISIS itself in this chip? Just IS up in the chip. So you're not running ISIS down in the vSwitch? No.
This
okay.
can be implemented on virtual research or physical research, physical switch.
Can you say it one more time? I didn't catch that.
It can be implemented either on virtual switch or physical switches,
Yeah,
as long as they are acting as NVEs.
So when we started modeling this in the IEEE and also in live deployments, where we have something called 802.1QCJ, which is an auto-attach function into an ISIS-based service in SPV. And what it does is simply says, what would be considered a VN inside of VXLAN is existed for quite some time in the IEEE for, since 802.1AH. And so to create that virtual network, we had the ability to automatically attach to it into OVS in the 2.3 or 2.4 release. And what we discovered is trying to make that work was extremely troublesome if you tried to actually participate in ISIS. You want to actually not be a part of ISIS, but be a separate leaf node off of the calculation, because the scaling issues are obvious once you start thinking about it, right? So there's a lot of modeling I think that we could learn from each other if this is where you want to go for helping VXLAN, trying to figure out how it scales without all the overlays. Just a little food for thought there. The functionality for it is been, the more I think about it, has been in 2.4 with live deployment. So you might want to take a look at that to see what you can learn as far as what's attaching. There's a whole lot of work and just, decisive that's been involved in that.
Okay,
Right.
thank you.
Yep.
All right. Thank you. Nimi?
My name is Naiming Shen, Cisco, and this is the draft I co-authored with Sharon and Mikhail. So which button?
This is actually the one.
Oh, this is the button. Oh, okay. So this is the version 4, and we just recently revived this one. And there is no particular protocol mechanism change, but we added multiple different use cases. Originally, this one was explicitly for the operation maintenance usage, but this is we added more in the new version, and we moved Tony Lee into contributor because he's completely concentrating on the applications instead of routing. And so the first use case is the one we designed this draft for, which is obvious. In the operation stage, the operators want to isolate a particular LAN interface or the entire LAN by doing simple signaling through one station and to reduce the traffic coming onto this particular nodes through this LAN or the entire nodes. And the second case, I actually personally have seen this as an issue from customers, but at that particular time, that particular customer is running OSPF actually. So the problem is we have a router in the network, the line card actually resets. The OSPF link immediately come up, adjacency is formed, and the BGP traffic is coming onto this line card, and it's a VPN traffic and get dropped because BGP has not finished downloading this one. So we see this as an obvious mechanism. You want to push a metric over this particular link to your neighbor saying, hey, why don't you increase your site's metric value on your outbound towards me, right? So to delay the traffic coming down on this specific link. And also the third case is obvious. And this is actually, we followed this OSPF two-way metric. It's exactly identical use case. You want to, from network to the node, also specifically when the truck is moving, you want to increase or decrease the metric on this particular inbounds in point to multi-points, that kind of environments. And also I have the later draft, which is a spine leaf extension. For spine leaf, you don't want to exchange any LSPs between them, but the thing is, if the spine node is overloaded, so you don't want the leaf does not have any information, just default to me, right? Because there's a lot of other guys you can default to reach the other leaf destinations. So this way, if you push a very large metric towards all the leads you are serving for, and you can give a signal, hey, wait a minute, the ECMP you need to treat me as a low priority. And also as a generic mechanism for IGP, especially on the LAN interface, currently there's no mechanism, right? How do you direct traffic away from that particular node, right? So this is quite powerful to give a inbound kind of indication. So this is nothing special. It's original. You have a metric, which is 3 octets. And you can optionally include the sub-TLVs for the TE metrics also to follow the same idea as the reverse metric. And we have a W bit, which is on one station. Sometimes you want one guy just to say, hey, let's raise the reverse metric for all the nodes on this LAN instead of just for me. So this is what this W bit is for. The S bit is for the sub-TLV. So the extension on the so for this one is as I understand the two-way metric. This one is not just for the LAN, and it's also for point, right? On the LAN, you have the hello to signal to the DIS. The DIS puts the reverse metric onto the original metric. Currently is 0. So on the point, you push the metric. You rely on the other side to add the metric on top of their original R-bound metric. So, and on the LAN specifically, as I mentioned, there is a W bit. So, not much special for the mechanism change. And yeah, this is has been a working group document for quite a while, and we want to know where to go next, right?
Do you have an implementation of this?
No, I don't think so right now. Do we have one? Yeah, no, I'm aware of right now.
Okay.
Any questions on this?
This is very useful, actually. It's long back when my old company, when we were discussing, we discussed it for one more use case. I don't need to bring it in here, but very useful tool, actually.
Okay, thank you.
Okay, so Pine Leaf.
So this is the co-author, and we first presented in last IETF in Berlin, and in this particular revision, and which is 02, originally the TLV has a metric value inside of the TLV. So we removed this one in this version because we are saying we already revived the reverse metric. We just used the reverse metric instead of put the same idea into one specific proposal. And so if you look at either in data center or in the campus, and the spine leaf or sort of spine leaf, that kind of topology is very popular. And normally the leaf to leaf or east to west traffic is goes through one of the spine nodes. So if this is the case, and we are thinking, why don't you just point a default to this one, right? Instead of learning all the LSPs and calculate the SPFs, and especially if you have a very rich mesh of the links, and during one node down, it can cause tremendous trouble of the flooding in this particular setup. And so this is, we are proposing just to get rid of the receiving on the leaf from the spines or the LSPs. And we still feed my own LSP from the leaf to the spine nodes. So the spine has all the information, but it will not flood back to me. So when we receive from the spine the signaling, yes, you can use me as a next hop. Then we can download the routes using default routes and the ECMP back to the spine nodes. And yeah, the flooding issue I have mentioned, this is one of the problems we try to solve. So if you look at this TLV introduced for this particular spine leaf, and there is just one flag field, and originally has a metric value, and it's been removed. So we are saying if you need to push a large metric back to the leaf nodes, just use the reverse metric. And so the operation is simple, is from the leaf nodes. Let's say here we have the aggregation layer, have 2 spine nodes, and the access layer, we have 3 leaf nodes. The leaf will signal through the hello with the L bit, says, and I want to be a leaf, and if the spine is okay with that, then the spine will set to the R bit saying, I'm willing to serve as the default next hop for you. So with that, and this is the operational aspects, and we are saying this only works on the point-to-point links. And the interconnections, we assume the spine nodes will have some interconnections between them. And if you are pure clause network, you may not have those horizontal connections between the spine nodes. And some networks in the data center, on top of the aggregation layer, they also have a core layer to interconnect all the spine nodes. So in that environment, it also works fine, right? And CSNMP is not needed over this link because it's just the optimization in the point-to-point case, and in here, it's not needed. And we also allow the local exchange between the leaves, and then you exchange real LSPs between the leaves, and you prefer the local routes over the default routes. And also, we suggest the leave, those guys should set overload a bit, because you do not want the traffic really going into the leaf, coming out back to the spine to reach some other guys. And we suggest, because the host name is carried in the LSP, right? Now you don't get an LSP for the leaves. So we are saying the host name in this particular case optionally can be put into the hello. So you know at least your spine's name through this. Yeah. So please do the review and the comments, and yeah, I would like to request the working group adoption for this draft.
Any questions?
Yeah, hi. Naming, I'm sorry, I actually did a pretty extensive review of this and I have a lot of comments and I didn't send them to you or the list. So I think I'd like to have those comments discussed on the list before we go to the working group adoption call.
That's great. Thanks.
David Lampeter. So we've implemented something rather similar for when we were trying ISIS for HomeNet, which was a tiny implementation that just set the overload bit. And it seems you're extending on that by adding functionality to not actually receive anything. So I think at least the approach in general seems to be viable to me. So
okay, thank you.
I also have a question. Couldn't you do the same thing? I mean, breaking the flooding graph using mesh groups?
Mesh groups.
Putting the leaf node, one link of the leaf node in mesh group 1 and the other one in mesh group 2.
Yes, you can, but you need to handle this in the administrative way, and this is only solving the problem to reduce the flooding problem, but we are talking about for certain devices, and it can be very restricted resources. And in this particular case, you don't want to receive the full routing table and the flooding information, which is not needed. This is the argument here. Yeah.
Okay. Then we go to geolocation.
Now, this geolocation and AC mentioned in the OSPF working group because he had too much fun and didn't have chance to get to this, and it's quite similar. But in the OSPF, we removed on the link to the link local signaling that portion and completely put back onto the RI link scooped the LSA. So, and also whatever the other changes is similar to what ISIS is going to present. Oops. Sorry, I just pushed the wrong button. And for ISIS, it was first presented also last in Berlin. And since then, and we have synced up with BGP, OSPF, and the Lisp to have a common header, a common format for this TLV. And we added, based on Elia and others' comments, specifically on the this privacy discussion, and we put the privacy section into the document also. And for use cases, and I mean, originally when we envisioned it was through a tunnel and underneath the routing, which is not controlled by ourselves, it's from another domain. So just for that particular reason, you do need to have, because you lost the sense of what is the distance, because the IGP or BGP is across a tunnel. It's directly connected to your neighbor, full meshed neighbor. So in that particular sense, we want to have a geolocation information to bring to the metric in order to select correctly the DMZ, the Anycast, the data center, you know, all those things. And we think also this helps all the P2MP mechanism. You don't have to explicitly define which one go to which neighbor using what kind of metric. This will help you dynamically automate this process. So, and all the other applications, you know, how to find your router and proximity services into the P2P streaming, that kind of cases. And
Naming, can you quickly wrap it up?
Okay.
We're losing the room in 6 minutes.
Oh, okay. So we optionally publish this in the LSP, and we also send through the RH for the metric help, that kind of indication signaling. And this is currently the, I don't want to go to detail, but the thing we added here mainly is the radius, that particular field, which the Lisp guys uses this one, and they want to define a geo prefix with the radius from 1 kilometer to the whole surface of the Earth. So we included and we synced up with the Lisp guys. So this is the format. Please read this, and we can discuss this. Privacy. So Elia and others, Alyssa and strongly suggested to incorporate some of the idea in their IFCs, like this one in 7459, and we added the section of the privacy section into the documents. So we would like to request for the working group adoption for this draft.
Any comments?
AC Lindum Cisco Systems. So the only difference in the OSPF, as Naming mentioned, is we took advantage of the fact that OSPF already has linked scope databases and all the implementations, and rather than tagging it, putting this on the end of the hello, we decided just to use the same encoding that's for the domain on the link with a link scoped router information LSA.
Thank you.
Stefano.
Hi, I'm Stefano Providi, Cisco. Small changes in the latest version of ISIS segment routing extension draft. We added a couple of sub-TLVs in the router capability TLV. One is the SRLB, so the advertisement of a range of labels that the node uses for local allocation. And next slide, please. It is used in order to advertise this label range to typically a controller, so that the controller, when he wants to instruct the node to a particular allocation, knows what is the range that the node reserved for that. We have the same extension in OSPF. We had a discussion in the OSPF working group, and a question has been asked whether this should be documented in the architecture. I rapidly answered yes, but I don't think, in fact, it changes anything in the segment routing architecture, so I don't know if it has to be documented. It's an optional TLV that a node may use to advertise a local label range for allocation. That's it. The use case is in the hands of the controller, where he may want to use this information or not. The other thing, next slide. We removed the text, same as in the OSPF draft. We removed the text about the preference between a prefix SID on a prefix sub TLV and the SRMS entry. We removed it because all these kind of aspects are addressed by the conflict resolution draft in Spring Working Group. Next slide. Well, I anticipate the next slide is another TLV in version 9, which contains the SRMS preference. Again, here we're just the messenger. So in ISIS, we just advertised a sub-TLV in the router capability TLV with a preference value for the SRMS. How to use this is defined in the conflict resolution draft in Spring. And finally, we added some description on the behavior of some sub-TLVs, the SRMS preference, DSRLB, and DSR capability sub-TLVs. Before that, the behavior was undefined. And now we have a specific behavior that says that if you have multiple occurrences of those sub-TLVs, you should prefer the first sub-TLV in the lowest number LSP. That's pretty much it.
Any questions? Super cool. We're done. See you in Chicago.
Have we talked before? In person? I don't think so. No? Yeah. I don't think so.
Okay.